National Fire Protection Association codes, specifically NFPA 70, the National Electrical Code, Article 517, covers the requirements for healthcare facilities. NFPA 99, the Healthcare Facilities Code, Chapter 3, includes electrical testing requirements. The American College of Healthcare Architects Guidelines, specifically the Guidelines for Construction and Equipment of Hospital and Healthcare Facilities, Chapter 8, provides guidance on electrical testing. Other resources include the American Society for Healthcare Engineering Healthcare Facility Design Guidelines, Chapter 9, which covers electrical systems and testing. The Facility Guidelines Institute publishes guidelines for healthcare facility construction, including electrical testing requirements. The Institute of Electrical and Electronics Engineers standards such as IEEE 3003, Electrical Practices for Hospital Environments, and IEEE 1100, Power Generation, Transmission, and Distribution, are also relevant. State and local regulations may impose additional electrical testing requirements, and it is important to consult with local authorities to determine specific requirements. Electrical equipment manufacturers provide specific testing procedures for their products, and these instructions should be followed to ensure proper testing and maintenance. Let's delve a little deeper into each of these resources. NFPA 70, the National Electrical Code, is a widely adopted standard for safe electrical installations. Article 517 specifically addresses healthcare facilities covering essential electrical systems, wiring methods, grounding, and other requirements critical for patient safety. NFPA 99, the Healthcare Facilities Code, provides comprehensive requirements for healthcare facilities to minimize the hazards of fire, explosion, and electricity. Chapter 3 focuses on electrical systems, outlining testing and maintenance procedures to ensure the reliability and safety of these systems. The American College of Healthcare Architects Guidelines offer architectural and engineering guidance for designing and constructing healthcare facilities. Chapter 8 specifically addresses electrical systems, including testing requirements to ensure that these systems meet the needs of the healthcare environment. The American Society for Healthcare Engineering Healthcare Facility Design Guidelines provide guidance on various aspects of healthcare facility design, including electrical systems. Chapter 9 covers electrical systems and testing, offering practical recommendations for ensuring the safety and reliability of these systems. The Facility Guidelines Institute publishes guidelines for healthcare facility construction that are widely used in the industry. These guidelines cover a wide range of topics, including electrical testing requirements to ensure that healthcare facilities are built and maintained to the highest standards. IEEE standards provide technical guidance on various aspects of electrical engineering. IEEE 3003 specifically addresses electrical practices for hospital environments, covering topics such as power quality, grounding, and electrical safety. IEEE 1100 provides recommendations for power generation, transmission, and distribution systems, including those used in healthcare facilities. In addition to these national standards and guidelines, state and local regulations may impose additional electrical testing requirements. These regulations may vary depending on the location of the healthcare facility, so it is important to consult with local authorities to determine the specific requirements. Electrical equipment manufacturers provide specific testing procedures for their product. These procedures are designed to ensure that the equipment is operating properly and safely. It is important to follow these instructions carefully to avoid damaging the equipment or creating a safety hazard. Here's a more detailed look at some of the key areas covered by these resources. Firstly, essential electrical systems are covered. Healthcare facilities rely on essential electrical systems to provide power to critical equipment and systems during power outages. These systems typically include generators, automatic transfer switches, and uninterruptible power supplies. Testing requirements for essential electrical systems are outlined in NFPA 99 and other relevant standards. Secondly, wiring and grounding are addressed. Proper wiring and grounding are essential for preventing electrical shocks and fires in healthcare facilities. NFPA 70 provides detailed requirements for wiring methods, grounding, and bonding. Thirdly, equipment testing is covered. Electrical equipment used in healthcare facilities must be regularly tested to ensure that it is operating properly and safely. This includes equipment such as patient care equipment, diagnostic equipment, and life support equipment. Testing requirements for electrical equipment are outlined in NFPA 99 manufacturer's instructions and other relevant standards. Fourthly, power quality is maintained. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can damage sensitive medical equipment and disrupt patient care. IEEE 3003 provides guidance on power quality management in healthcare facilities. Fifthly, electrical safety is paramount. Electrical safety is a critical concern in healthcare facilities. NFPA 70 and NFPA 99 provide detailed requirements for electrical safety, including requirements for ground fault circuit interrupters, isolation transformers, and other safety devices. In addition to these specific areas, the resources mentioned above also cover a wide range of other topics related to electrical testing in healthcare facilities. These topics include documentation, record keeping, and training. It is important for healthcare facilities to develop and implement a comprehensive electrical testing program that addresses all of these areas. Now let's discuss some of the specific tests that are typically performed on electrical systems in healthcare facilities. Firstly, visual inspection. A visual inspection is a basic but important step in electrical testing. It involves visually inspecting electrical equipment and systems for any signs of damage, wear, or corrosion. Secondly, insulation resistance testing is used. Insulation resistance testing measures the resistance of the insulation surrounding electrical conductors. This test can help to identify insulation breakdown, which can lead to electrical shocks and fires. Thirdly, ground impedance testing is needed. Ground impedance testing measures the impedance of the grounding system. This test can help to ensure that the grounding system is functioning properly and can safely conduct fault currents to ground. Fourthly, leakage current testing is also important. Leakage current testing measures the amount of current that is leaking from electrical equipment to ground. Excessive leakage current can indicate a problem with the equipment and can pose a shock hazard. Fifthly, polarity testing is done. Polarity testing verifies that electrical outlets and equipment are wired correctly. Incorrect polarity can create a shock hazard. Sixthly, functional testing should be performed. Functional testing involves testing the operation of electrical equipment and systems to ensure that they are functioning properly. This may include testing the operation of lighting fixtures, receptacles, and other electrical devices. When implementing an electrical testing program, it is important to firstly develop a written plan. The plan should outline the scope of the testing program, the frequency of testing, the procedures for testing, and the documentation requirements. Secondly, train personnel. Personnel who will be performing electrical testing should be properly trained in the procedures for testing and the safety precautions that must be followed. Thirdly, use calibrated equipment. Electrical testing equipment should be calibrated regularly to ensure that it is providing accurate readings. Fourthly, document results. The results of all electrical testing should be documented and maintained for future reference. Fifthly, take corrective action. If any problems are identified during electrical testing, corrective action should be taken to address the problems. Furthermore, maintaining compliance with electrical testing requirements is an ongoing process that requires a commitment from all levels of the healthcare organization. By following the guidelines and recommendations outlined in the resources mentioned above, healthcare facilities can ensure that their electrical systems are safe, reliable, and compliant with applicable regulations. This commitment to electrical safety will help to protect patients, staff, and visitors from the hazards of electricity. Here is some further guidance on the application of some of the mentioned standards. Firstly, NFPA 70 application. NFPA 70, the National Electrical Code, provides the foundation for safe electrical installations in healthcare facilities. It details requirements for wiring methods, overcurrent protection, grounding, and equipment. When applying NFPA 70, pay close attention to Article 517, which provides specific requirements for healthcare occupancies. This article addresses essential electrical systems, isolated power systems, and other unique aspects of healthcare electrical installations. Secondly, NFPA 99 application. NFPA 99, the Healthcare Facilities Code, focuses on minimizing fire, explosion, and electrical hazards in healthcare facilities. Chapter 3 outlines essential electrical system requirements, including performance criteria testing and maintenance. When applying NFPA 99, ensure that the essential electrical system is designed, installed, and maintained to provide a reliable source of power during disruptions of the normal power supply. Perform regular testing and maintenance to verify the system's performance and compliance with NFPA 99 requirements. Thirdly, ACHA guidelines application. The American College of Healthcare Architects guidelines provide architectural and engineering guidance for healthcare facility design and construction. Chapter 8 addresses electrical systems, including testing and commissioning. When applying ACHA guidelines, consider the specific needs of the healthcare facility and incorporate design features that enhance electrical safety and reliability. Follow the guidelines for testing and commissioning to verify that the electrical systems meet the design requirements and are operating as intended. Fourthly, ACHA guidelines application. The American Society for Healthcare Engineering Healthcare Facility Design Guidelines offer practical recommendations for designing and maintaining healthcare facilities. Chapter 9 covers electrical systems, including testing and maintenance. When applying ACHA guidelines, focus on implementing best practices for electrical safety and reliability. Conduct regular inspections and testing to identify and address potential hazards. Follow the guidelines for maintenance and repair to ensure that electrical systems are operating at peak performance. Fifthly, FGI guidelines application. The Facility Guidelines Institute publishes guidelines for healthcare facility construction, including electrical testing requirements. These guidelines cover a wide range of topics, including electrical systems, emergency power, and grounding. When applying FGI guidelines, ensure that the electrical systems are designed and installed in accordance with the latest edition of the guidelines. Follow the guidelines for testing and commissioning to verify that the electrical systems meet the performance requirement. Sixthly, IEEE standards application. IEEE standards provide technical guidance on various aspects of electrical engineering, including power quality, grounding, and electrical safety. IEEE 3003, Electrical Practices for Hospital Environments, and IEEE 1100, Power Generation, Transmission, and Distribution, are relevant to healthcare facilities. When applying IEEE standards, select the standards that are applicable to the specific electrical systems in a healthcare facility. Follow the recommendations in the standards to enhance electrical safety, reliability, and power quality. Furthermore, stay updated on the latest revisions and interpretations of these standards and guidelines to ensure that the electrical systems in the healthcare facility are in compliance with current requirements. Now, let us consider the importance of understanding the differences between the standards and guidelines. Standards are typically mandatory requirements that are enforced by regulatory authorities. Guidelines, on the other hand, are recommendations or best practices that are not necessarily mandatory. However, following guidelines can often lead to improved safety and performance. When applying standards and guidelines, it is important to understand the differences between them and to comply with all applicable mandatory requirements. It is also important to consider the recommendations in the guidelines and to implement them to the extent possible. Lastly, state and local regulations may have electrical testing requirements that are more stringent than the national standards and guidelines. Always consult with local authorities to determine the specific requirements that apply to the healthcare facility. In summary, electrical testing in healthcare facilities is a critical aspect of ensuring patient and staff safety. By adhering to national standards, guidelines, and local regulations, healthcare facilities can create a safe and reliable electrical environment. Understanding and applying NFPA 70, NFPA 99, ACHA guidelines, ACHA guidelines, FGI guidelines, IEEE standards, and state and local regulations is paramount to establishing a comprehensive electrical testing program. Continuous education and training for personnel involved in electrical testing are essential to maintain compliance and promote a culture of safety within the healthcare facility. Remember that electrical testing is not a one-time event but an ongoing process that requires continuous monitoring, maintenance, and improvement. By prioritizing electrical safety and investing in regular testing, healthcare facilities can minimize the risk of electrical hazards and ensure the well-being of patients, staff, and visitors.